Hello everybody, this is John Brewer. This week on Large Ship Combat 101, we'll be talking about gravity shields. Last week, we discussed gravity cannons and missiles with gravitational engines. Gravity provides tremendous advantages to the attacker in terms of range, speed, and power. The shotgun-like blast of an item-firing gravity gun can overwhelm the point defense of a target. Fortunately for defenders, gravity can also be leveraged to protect ships. First, let's put a little scope on gravity-based defenses. Gravitational shields affect projectiles that have gravity physics enabled. Those would be item projectiles, and ship-based projectiles with an activated artificial mass block. Missiles, bullets, and ships without artificial mass blocks will be unaffected. The goal of gravitational shields is to deflect a projectile that would hit the ship, so it does not. We build the gravity shields using linear and spherical gravity generators. Linear gravity generators create a cuboid field with a consistent gravitational effect throughout. Spherical gravity generators create a spherical field that always pulls objects toward or pushes them away from the generator. The simplest way to deflect projectiles from a ship is simply to install a spherical gravity generator on board, emitting a -1g field. This field will exert a gravitational push away from the ship in all directions. By using multiple spherical generators, the g-force exerted on projectiles can be more than enough to deflect or even reverse inbound fire. This solution has a few issues, though. The spherical gravity generator will exert a force on all gravity-sensitive objects aboard the shielded ship. The shield can interfere with other gravity-based systems aboard the ship, such as engines or cannons. Spherical shields will need to be disabled or otherwise compensated for before these systems can be safely or effectively used. Powerful spherical shields can make moving around ships that are moving inertially difficult, as walking without a jetpack may be impractical or even dangerous. Finally, spherical shields draw considerably more power per volume to generate a gravitational field, and frequently over half of that volume isn't helping deflect fire threatening the ship. Due to these disadvantages, linear shields are sometimes a more viable option. Linear shields have a much shorter range than spherical shields. Because they are always at the center of their field, linear generators will either waste half of their field size, or they will need to be placed on wings as much as 75 meters from the hull. Linear generators are most effective when they're used to deflect fire away from the center line of the ship, rather than attempting to push the projectiles straight back. Because the shield around the ship is made up of multiple generators, particular parts of the shield can be deactivated to avoid interfering with key systems, like gravity engines, without lowering the entire shield. Pistons and rotors can also be used to reshape the gravity field under combat conditions, to open or close firing lanes for cannons. Now, let's get to the crux of the shield. How much shielding is required to turn a dead center hit into a miss? I'll go over this using the Nervous Gamma frigate as a case study. First, let's look at the spherical gravity generator model. This ship has no gravity cannon or gravitic engine, and it only has a crew of 1. It is designed redundantly to continue operating after a hit anywhere aboard, so there shouldn't be much need to move about the ship during combat. As a result, it is an ideal candidate for spherical gravity shields. Let's consider a dead center shot coming in fast. Let's say 120 meters per second. With 1g of repulsion starting at 400 meters, the shot will hit the ship about 4 seconds after encountering the shield, still traveling around 81 meters per second. With 2g's of repulsion, though, the shot is stopped 6.1 seconds after encountering the shield, some 32 meters away from the generator. If the shot is coming in a beam, this is plenty, but around to the bow or the stern will still hit the ship. 3g's of repulsion solves the problem entirely, but now our shield demands almost 135 megawatts of power, more than the large reactor on board can provide. Stopping and reversing the round with linear gravity generators on the hull would take about 12 generators per facing. This is more energy efficient than using a spherical generator, but considerably less mass efficient. Of course, we don't need to stop and reverse the round. We just need to deflect it enough that it misses the ship. The frigate is only 40 meters tall, so we only need to move an incoming round at most 20 meters up or down over the 150 meter field of a linear generator in order to turn the hit into a miss. Instead of hull mounting our linear gravity generators, we can put them on wings extending 75 meters out and 75 meters above and below the ship, to ensure shots will pass through the entire field before encountering the hull. As a rule of thumb, a fast shot passing through the full 150 meters of a gravity generator's field will deflect 5 meters in the direction of the gravity field. If we assume shots come in perpendicular to the field, we can protect the ship with only 16 to 20 gravity generators. This strategy relies on the ship keeping its beam toward the threat axis, though. It is still vulnerable to shots from directly above or below. All of these calculations, of course, rest on the assumption the ship is at rest in the game world. A ship underway can find itself with incoming fire at a relative velocity well above what we've discussed here. This has been a very quick review of gravity shields in Space Engineers. Come back next week when we'll talk about sights and firing solutions. Until then, I'm John Brewer. Come and learn from my mistakes.